Good afternoon, ladies and gentlemen of Algebra 2 Honors. In this exercise set, it says find the LCD for each set of rational expressions. Did we talk about why an LCD, why finding the least, an LCD stands for what? Least common denominator. Thank you. Why is it helpful to know what the LCD is? Okay, to remind you, in case you need reminding, is your LCD is what you're going to be able to do if this is an equation. To solve this equation, when you multiply it by the least common denominator, you're going to clear out the denominator and have a more easily solvable problem. So that's why you're going to do it. So the steps to finding the LCD are first to factor each denominator. So if we have 2x plus 16, what is 2x plus 16 in factored form going to be?
2 times x plus 8.
Okay, Jace says 2 times quantity x plus 8. Is that right? Yeah, that's right. Good job. And next one we have is 3x minus 27.
Which will be 3x minus 9.
3 times quantity x minus 9. And so what you're doing for your LCD, you're looking for the least common denominator by which you're going to be able to multiply and clear everything out. And so if you see these things right here, do you have any ideas on what the least common denominator is going to be for this? What's your idea on this? Anybody? Well, to clear out, to clear, I don't know where you got 72 from. Okay, you're going to need to pick, you're going to need to have x plus 8, you're going to need to have x minus 9. These are necessary components of your LCD. And what else are you going to need to have?
2 and 3.
So what do you do with the 2 and 3?
Multiply them?
Yeah, you can multiply them together. Now, and so you get 6. Now, let's say instead of 2 and 3, let's say instead of that you had 9 and 3. What would be your LCD if you had 9 and 3? What would be your least common denominator if you had 9 and 3?
3.
No? Because 3 isn't going to clear out. 3 will clear this out, but a 3 won't clear this out. Okay, what do you have to have? If you have a situation like this, your least common denominator is going to be 9. Because 3 is included in that as a factor of that. So we'll see more like that. So, okay, but 6 is the answer to this here, all right? And that means when we multiply these fractions on either side by this, we're going to clear everything out of the denominator so that we'll be able to solve the problem using a linear equation or possibly a quadratic equation.
Okay, I got 72 because I was multiplying x plus 8, x minus 9.
Oh, okay, yeah, you were expanding. This is like it was a binomial, like you're expanding a binomial. Yeah.
Yeah,
that's what you do.
That's
what we're doing in these things here, we're leaving these things in factored form also. It just makes our, then we actually solve this, we put this in factored form and do it that way. Okay. So I won't erase it. What I want to do is I want to choose somebody to work to do number 4. So once you do number 4, similar fashion, I'll choose somebody here. And let me get to my wheel here. I've like set a few people down. Seven. Okay. Okay, number 4. Number 4, we got Victoria. What do you think, Victoria?
So, I don't know if I did it right, but for the 5x minus 40, I got 5, and then parentheses x minus 6.
So like this, okay?
And then for the 7x minus 42, I got 7, parentheses x minus 6.
Okay. So what, based on this, will be your least common denominator?
Is it 35 and then parentheses x minus 6? And then parentheses
So like this?
yeah.
And we also do x minus 6 as well.
Yeah, now here's what it is that because each of these denominators really contains x minus 6, you only have to list it once. So, so what we would have is our least common denominator is going to be actually this, right? Because x minus 6 is within each of those, and so that same x minus 6 will cancel out, because you only need to cancel out one at a time when you multiply it out by that. Okay, does that make sense? So if it appears in both places, you only need to list it once as a least common denominator. All right. So let's go look at number 5. That off, okay, on here. All right, we have this one here. I'm going to choose somebody again, but let me. We have. Okay. So I will choose somebody, and just a few people left here. Okay, we have for this one, we have Abigail. Oh. All right, Abigail.
I'm still in the middle of.
Okay.
Okay, so far I did the x squared minus 3x minus 28. And, oh wait, which one are we doing? 5?
5.
Okay, I was working on 6, ignore that part. So for the x squared plus 5x plus 6, we're supposed to factor them, right?
Yes.
Oh, thank goodness. Okay, so I got parentheses x plus 2 close parentheses, and then parentheses x plus 3 close parentheses.
Like this?
Yeah.
Okay.
And then for 10x plus 20, I got 10 parentheses x plus 2 close parentheses.
Okay.
And then so for least common denominator, I got 10 parentheses x plus 2 close parentheses, and then parentheses x plus 3 close parentheses. Because you said that if it's got two of the same one on the payroll.
Right. And let's talk about the reason for that too, because that's what's really important concept here. Because when we actually solve this equation, if like this is an equal sign, if we multiplied everything by that, it would, the x plus 2 is here and it's over here. So when we multiply each side by that, just that one x plus 2 will help clear out each of those denominators. That's why. Another x plus 2 there isn't going to help us though. It's just going to make it things more complicated. All right, good work. Why don't you go ahead and work on number 6, and we'll call on somebody for that in a minute. Okay. We have we're going to have, looks like Brian. Okay, Brian, we got you for number 6. I don't see why not. Okay, x squared minus 3x minus 28. Then we got x squared minus 2x minus 24. Okay, what are these going to be factored out?
So x squared minus 3x minus 20 would be x plus 4 and x minus 7.
Okay, that looks like a good factoring to me, doesn't it? Because you got the plus 4x and the minus, oh yeah, that looks good. Okay, and this next one here?
One would be x minus 6.
X minus 6.
And then x plus 4.
X plus, what did you say it was?
4.
4, okay. All right. Now we have factored. We're going to go ahead and determine our LCD. What's going to be our LCD based on these two denominators factored?
So that would be x minus 6 times x plus 4 times x plus minus 7.
That's supposed to be x plus 4, okay. Questions on that?
And I do correct.
Does that look right? Steve, does that look right? Yeah, this is right. Good job. Okay, here we go, Brian.
2 stars.
Very nice. Okay, we get 7 and 8. Seven and 8. Okay, here we go. So we got, let me go ahead and, before I choose somebody, I'm going to write down what these are. We got 3x squared minus 21x minus 54. And we got 21x squared minus 84. All right. Let's see who we have here. We have have Steve-O or Jace probably. Looks like it's gonna be Jace. All right, Jace. What do you think?
Can't look factor the ones just three from the next.
You can't? Let me make a suggestion. I want to show you something here. What if you took 3 out here and made this x squared? And what divided by, if you take 21 divided by 3, what's that? 7. And last thing, what's 54 divided by 3? 18, okay. And now can this be further factored here? Okay, what you're looking at, got a minus here. So you're looking for two numbers that multiplied together equal 18, but the difference between them is 7. So -9 and +2. Okay, I think that's right, because you got 9 minus 2, okay, good. And then this one right here, this 21x squared minus 84, what's that going to be? What's your common factor here? 7 is common, but there's a bigger common factor than 7. Yeah, 7 would work, because 7 is divisible into each of these things. But there's a bigger number that's divisible, is divisible into both of those, 21 and 84. What's that? Yeah, 21. It's got 21. What's that going to be? X squared minus 4. And what's going to be our final factoring on this thing here? 21. So x minus 2, x plus 2. Okay, good. So now we can determine, we can get our LCD here. So our LCD, our least common denominator between these two is going to be what? Okay, 63 is a common denominator, but it's not the least common denominator between those two.
Don't you multiply them?
You could to get a common denominator, but not necessarily the least common denominator. Okay, 63 is a common denominator because you guarantee it when you multiply together, but there's a smaller common denominator. There's a least common denominator. Someone else know what that is? No, 3 is not going to work because 3 will take this out, but it won't take this out. We need a number that takes both of these out. That's the smallest number that will take both of these out when we multiply out. What's that going to be?
21.
Okay, Riley says 21. He's right. Okay, why is 21 going to be the least common denominator? Because what does a 21 do?
And 3 can go into 21.
Yeah, see, it'll take out this 21 and also take out this 3 as well. So yeah, so Jason's right, because once you multiply these together, you do guarantee that you have a common denominator, but the least common denominator here is going to be 21. Okay, thank you, Riley. Okay, Jace, what else do we have here?
X minus
X minus 2, X minus 9. Anything else? There's one more that appears in both places.
Don't those cancel out?
No, you're not dividing them by each other.
But on the other ones,
Okay, they're going to be X plus 2. You need that too. When you multiply by all this, you're going to cancel everything out. Okay?
With the minus 2 and plus 2.
but there's plus 2 on both.
Yeah, that means you need it. You need it if it only appears in one of them, but you need it. It even helps you more if it happens to be in both of
Take
them.
one of them, like you wouldn't like this.
Okay, thank you, Jace. Now,
It's gonna slow you harder, isn't it?
yeah, what it is, I want to show you this one here. The next section is actually using the least common denominator to solve these.
Is those still 8?
Pardon me?
So we used to have to do 8 before you go.
Oh, we have to do 8, that's right, I forgot.
Hold up.
Yeah, you're right, you have to do 8. Steve-O, you're going to have to do 8 for us. Because you're the last guy I have to call on here, Steve-O.
Oh, yeah. I'm sorry, I was just really full of what.
Steve-O, what I want to do, before you do that one, I want to recommend something here. I don't know, you probably already are doing it. 5x squared minus 40x minus 60. Okay, this one here, what I recommend doing to make your life easier is to factor out a negative sign. So we'll have negative 7x squared minus, 56x minus 84. Okay? That's just going to make your life easier. Whether you, I don't know if you had the idea to do that or not, but
Would it get done that all the time? Or does that only work on this one? Does that only work on this one, or does it work the whole time?
well, what it is, we're trying to make this thing down here easier to factor. And it's going to be easier to factor if we get rid of that negative sign. But if we to make 7x squared positive, we're going to have to make this negative and this negative to have equivalent expression. Okay?
I thought you were subtracting versus there, but
No,
because subtracted the whole time.
no, I'm not subtracting. I'm just listing two separate denominators here. All right, Steve-O, what do you get?
You can take out 5 on the top
Okay,
one,
so we get 5.
and you won't be able to simplify it anymore.
So x squared
X squared minus 8 minus
8x.
12.
minus 12, okay.
You can't simplify it anymore because it's negative.
So this is non-factorable here is what you're saying?
Yeah.
Okay, go ahead.
If everything was positive, then it could, but yeah.
Yeah,
You take out 7 on the bottom.
okay, I'm going to take out negative 7. Okay.
Yeah, negative 7.
Okay,
It would be the same thing as the top.
okay, so x squared minus 8x minus 12.
Yes.
Okay, and so what is going to be,
Negative 35 x squared minus 8x minus 12.
okay, yeah, that's going to be it. Okay, in the next section here, we're talking about solving rational equations. And based on what I saw second period, this was like a quantum leap of hey, let's figure out what's going on
This
here.
is like building a quantum computer, you can't understand that, how to build it.
Okay.
You can stop me.
Feel me?
But what I try to be careful in explaining today especially that the reason we're getting a least common denominator is to be able to have something to multiply by to cancel things out. So I try to be clear about that. So let's go to number 9. Okay, solve each rational equations algebraically. Well, what we're trying to do when we solve rational equations, we're trying to do something that is called clear the denominator. And even though it doesn't say it here, that one thing you have to be concerned with when you do this is, what is one thing you have to be concerned about with this that we've talked about? Not today, but last Thursday, Wednesday, what have we talked about?
I honestly don't remember anything from this.
You don't? That's been a long Easter weekend since then, right? Yeah. Okay, we have to worry about excluded values too. Okay, so let's go ahead and find what is going to be our least common denominator from all these denominators here. And obviously we don't have any factoring to do, but what is going to be our least common denominators from these 4x and 6 and 12x?
Wouldn't the 6 be negative?
I'm not going to worry about negatives right now. Yeah, I'm not going to worry about negatives. I'm just talking about looking at 4x and 6 and 12x. What is going to be
Wouldn't it be 12x?
our least common denominator? Steve-O says 12x, and let's go ahead and try that. Now, is 4x included within 12x?
Yeah.
Yeah, it is. Is 6 a factor of 12x also? Yeah, it is. And so 12x is going to be a least common denominator between all those. Okay? And next we're going to find, we're going to list here our excluded values. And actually there's just one excluded value. What is that going to be? X cannot equal?
0.
X cannot equal 0. Thank you, Abigail. X cannot equal 0. That's our excluded value. And so now we're going to work this problem out, and what we're going to do is multiply every term here by our least common denominator. And if this is the least common denominator, it's going to succeed in doing what? Clearing the denominator. So here, I'm going to write the first one out is 9 over 4x. I'm going to multiply by the least common denominator, which is 12x. And I'm going to put minus 5/6 and multiply it by the least common denominator, which is again 12x. And on the right side, we have negative 13 over 12x. And what's our least common denominator? 12x. And now we can simplify things a little bit here. What's 12x divided by 4x? That's going to be 3x. No, it's going to be 3. Because x will cancel out, right? So we're going to get is 9, I'll say 9 times 3. And then for this one here, what's 12x divided by 6? 2x. So we have 5 times 2x here. And the last one here, the right side of the equation, what cancels out here? 12x and 12x. So we have minus 13. And so we have 27 minus 10x minus 13. And what is that going to be?
You have to combine the 27.
That's
and
equal, excuse me, it's
Oh.
equals. What do we have to do here?
Subtract the 27.
Let's subtract 27. And I'm going to continue to work to the right here, so that cancels out here. So we have negative 10x is equal to negative 40. And so x is equal to 4, because we're dividing by negative 10. And the last thing you do is you check if this happens to be an excluded value. Okay, since x equals 4 is not an excluded value, then x equals 4 is a real solution. Now, what would a x equals 4 have been if it happened to be an excluded value? We would call it we call it, in this case, we call it an extraneous solution. It's one that turns out to be a non-real solution in this one. Okay, so that's going to be number 9 worked out. And I want you to go ahead and work on number 10. And just work that out, and then we'll kind of see how it goes. I'll either choose somebody, or I'll just show you how to work that out. How's that? Can you work on number 10? So we'll work on number 10. What's our least common denominator going to be for number 10?
7 parentheses x plus 1.
Okay, Steve-O says 7 parentheses x plus 1. Yeah, that's your least common denominator. And is that 2 confusing anybody on the right there?
It's 2 over 1.
It's 2 over 1. Very good. You got sharp people here. Okay, for this one, can I choose somebody, or do I need to work this out myself to show you how to do it? Still working on it. What do you think? Should I choose somebody to do number 10? Or should I work it out?
Choose someone.
Give them time.
You should choose someone.
Yeah, I'll choose somebody. We'll work whatever it is. Steve, I told you what it is. I'll choose somebody here. I got. Okay, here we go. We've got. Okay, we have Abigail.
I have no clue what I'm doing here. Can
Okay.
I pass it off? Please let me pass it off.
Really?
Yes, because I have no clue what I'm doing here.
All right.
Only you, Steve.
So this time we're gonna get Steve or Victoria. Looks like Victoria.
Thank goodness.
I don't know what I'm doing either.
You don't know what you're doing?
How am I on the board? I already did one. It's because we just
We ran out of people, had to choose and do them.
I don't know what I'm doing either. I think you should give it to Steve since he's the one that wanted to.
Yeah,
mark it
Steve-O
out.
would have been the next, he was close to being picked, so I just, okay, Steve-O, what do you think?
Okay, you had lost,
Let's pay attention. Let's pay attention here. Okay.
because the least common denominator is 7x plus 1, you could cancel out x plus 1 on the 3 over x plus 1, that will be 37.
Okay, let's talk about excluded values too. What's our excluded
So
value?
yeah, it will be -1.
So x cannot equal -1. Okay, let's go ahead. So we have,
You cancel out the x plus 1, so it will be 3 times 7.
hang on a second, 7, x plus 1. I want to show everybody here. So you're multiplying this thing by 7x plus 1 plus 2/7 times 7 times x plus 1. And then over on the right side here, you have 2 times 7 times x plus 1.
Yeah.
Okay, go ahead.
You'll cancel out the x plus 1, so it'll be 3 times 7, which is 21.
Times 7, okay, 3 times 7.
And then you cancel out the 7 on that, so it'll be 2x plus 2. Then you,
X plus 1, right?
yeah, but once you times 2 by it, it'll be 2x plus 2.
Okay, I'm just going to leave it in this form first. Okay, I want to do it once. Now over here, what do you have?
2 times 7 times x plus 1.
Okay, so that's going to be 14 x plus 1. Okay, now what do you have? I'm just going to 21 plus 2x plus 2
Yeah,
equals
14x plus 14.
14x plus 14. Okay,
Then you could add the 21 and 2 to get 23.
23 plus 2x,
Equals 14x plus 14.
14x plus 14.
And that's where that's
Okay.
where
So now what we're going to do is, we're going to go ahead, I'm going to subtract 2x from both sides,
Just subtract it to these.
and then subtract 14 from both sides.
Yeah, and then you'll.
I'll have 9 equals 12x. And so x is going to be equal to what?
3/4.
3/4?
Yeah.
Is 3/4 an excluded value here?
No.
No. So this is called real solution.
Okay, yeah,
Okay, thanks class. Thanks for working right to the end. Appreciate that.
you all.
Yeah, well, I'll give you
Can you fix
credit,
my
Steve.
brain?